Hey YouTube. So Power Queen has sent us their newest model of 100 amp hour battery. I don't have a whole lot of information about it, so we're going to have to explore it. But this is supposed to be some kind of smart battery. I don't think it has Bluetooth, but it has some kind of smart functionality. So we're going to explore it and figure out what that is. So let's open it up. Nice little packet. Okay, let's see. Operation guide for beginners. Let's read it. It says we're going to receive it at 30 to 50% capacity, which is pretty normal. It says to fully charge it before using it. We always do. It says avoid contact between the terminals of positive and negative. That's a good piece of advice. It's capable of handling a 50-watt lamp, a 100-watt television, 800-watt microwave, 1,000-watt, looks like a juicer, 1,200-watt refrigerator, and a 2,000-watt, I don't know. Anybody know what that little icon is? Looks like a printer, but I don't think a printer would be 2,000 watts. Do's and don'ts. Do not install the battery upside down. It's recommended to store between 10 Celsius and 35 Celsius at 50%. So when you store these batteries, this is across the board. If you're going to store these for a long period of time, store them at 50%. If you store them at 100%, it's actually going to degrade the battery a little bit, and it won't last as long. So if you're going to store these, let's say this is maybe it's in one of your recreational vehicles, and you only use it a few times a year. When you're done using it, you need some kind of shunt to tell you what state of charge your batteries are, and if they're too high, then you'll need to run some loads and bring them down, around 50%. It says do not disassemble the battery, which is probably a good idea, but we are actually going to disassemble the battery. Power Queen has requested that I actually tear it apart, which is great. So we are going to tear down this battery. They want to know how good the build quality is from the professionals. I'm flattered that they consider me a professional. So we're going to tear it apart and we'll let them know what we think about it. So 12.8 volt, 100 amp hour smart version. This is what I was talking about. So this is a smart version, 100 amp BMS. The charging voltage is 14.4 plus 0.2, which is very common. We'll test that to make sure it actually gets to charge to that level. Max continuous load power is 1,280 watts, so basically 1C. Max continuous charge discharge current is 100 amps, which is again 1C. Has M8 terminals and one touch control button. So okay, this is where it starts to get into the smart thing. So we're going to have to figure out what that button's about. It is 8.07 inches tall, or 205 millimeters tall. It is 8.13 inches or 206.5 millimeters in depth, and it is 10.79 or 274 millimeters wide. OTCB, one touch control battery. One touch button to control the battery on or off. Okay, that's nice. So you can actually turn the battery off. I guess if there's any loads possibly connected to it, it won't be sitting there draining it down. And it'll also put it in a safer state so things won't be able to short out on it. It has a battery status monitoring via the LED. And it does have low temperature charging protection. Ah, fantastic. This is a very rare but desired feature. Low battery capacity remind, intelligent sleep mode, and one touch sleep mode activation. Has a user-defined low temperature forced charging in emergency situations. So I guess it does have low temperature cutoff, but you can override it if you definitely need to. Well, I guess if you're in some kind of emergency situation and you need it to charge your battery. It's showing us how to connect it. Recommended charge current is 0.2C, which is 20 amps. Maximum discharge current is 300 amps to 500 amps for 5 seconds. Continuous load is 100 amps or 1,280 watts. So here's the instructions for the one button, one touch functions. Tell you what, let's pull the battery out and then we'll go back to the manual if we need to. This is where the bolts are going to be, as we've seen on other batteries. And it does indeed come with 2 sets of bolts, as with other batteries. All right, let's pull this bad boy out. I can already tell this is going to be a different form factor than the other batteries because it seems a little more square than the rectangular. Nice foam packing as always. And there the battery is. So let's see if we can get it out. Yeah, it definitely does have a different, slightly different shape than what we are used to. Let me pull out another battery to compare. So this is the common one, the common size form factor that we are used to. It's a more rectangular shaped battery, and this one is more square. So let's put them side by side here. We can see that this one is a little more square. This one's longer. And as we can see on the side here, this one's wider and this one's a little thinner. And a little bit shorter on the new battery. The weight feels about the same. Okay, so let's check the voltage. It should be off because I think we're going to have to do something with this smart button. And so at which point we'll have to refer to the manual. Yeah, so it's showing like 3.2 volts DC. So let me take a peek at the manual and see how we power it on. So a short press will power it on. So let's see. I don't see anything. Let's try that again. There she is. There we go. 13.1 volts. And then it lights up green. A long press powers it off. So let's try. Let's try one more short press and see what it does. Okay, so nothing. Long press. There we go. And it's off. I saw the light turn red. Let's try short press. So you have to have a little bit longer than a short press. So it's like maybe a second or something like that to turn it on. And which is good because, you know, if you have this somewhere, you don't want something to bump it and then turn it on, and it may be short. So long press, it's red and it goes off. And now we're down to the 3.2 volts. 1 second press and it's back on. Oh, it even says in the manual that short press is a button that's held for 1 to 2 seconds then released. A long press is a button that's held for 2 to 3.5 seconds then release. So you can series up to 4 and parallel up to 4, which is fantastic. So we're going to charge it up, and it says the recommended charge current is 20 amps, but the max continuous charge and discharge current is actually 100. So we're going to actually charge it up at 50 amps. Alright, so we have the Adroit 50 amp lithium iron phosphate 12 volt charger, and we're going to charge this battery up to full. Let's plug it in. We are charging. And when this is fully charged, we'll come back and do some more testing. All right, you guys, the charger shut down, and it's been resting for a little bit after the charger shut down. So we're currently resting at 13.4 volts. So right now what I want to do is turn the charger back on, and I want to see what it actually charges up to. Does it charge up to the 14.4 volts plus or minus 0.2 that is stated in the manual? That's what I would like to see. So I'd like to see it at least get to 14.2, but preferably 14.4 and possibly 14.6. That will tell us how well the cells are balanced and how well they're matched. So let's plug in the charger again. It's back on, so now the voltage is rising. We're at 14, 14.2, 14.4, 14.5. Okay, so it shut off at 14.52. That is fantastic. That's a good place for it to be able to shut off at. That means that it meets the specifications in the manual, and the cells should be quite balanced and well matched. Otherwise, sometimes if these batteries shut off a lot lower than what it's specified to shut off at, that would indicate that there might be an imbalance in the cells, or there may be in addition to possibly the cells not being very well matched when they built the battery at the factory. Okay, now that the battery's all charged up, we're going to set it up to do a discharge test. All right, guys, so we have the shunt set up for us to do a discharge test. I've got a heater down here that'll act as the load plugged into this inverter. So let's turn the inverter on and we can start the capacity test. There we go. And we are drawing 64 amps, which is quite a bit more than a 0.2 C test. I typically skip 0.2 C test because with lithium iron phosphate, there's very little difference between a 0.2 C and even a 1 C test. So it should pull full capacity. If it doesn't, then we'll recharge it and then we'll do a 0.2 C test to give it one more chance. But anyways, we're going to let this run, and when it completes, I'll be back. Alright guys, the test is still going. We still have 11% left. But there was something that I noticed, and when I was reading the manual earlier, it was talking about this LED indicator, part of the smart function. If it's flashing green, then it's low capacity, and that means it's lower than 25%. So lo and behold, we are down below 25%, and that button is flashing green. So that function does work. That's pretty neat. That's a pretty handy function. Very easy for you to glance at the battery and see that it is less than 25%. I just wanted to show that real quick. Anyways, I'm gonna let this continue to run, and I'll be back as it approaches completion. All right guys, we are down to 1%, and we're about to pull full capacity. We're at 99.9 amp hours, 1255 watt hours, and there we are. We just completely pulled 100 amp hours, And we're gonna continue to let it run to see how far it goes. This guy's still flashing green over here, of course indicating that it's below 25%. With 11 volts, now I'm curious what the manual, the smart stuff in the manual says about whenever it's fully discharged. What does it do? What does the light do? It says 10.8 volts is the recommended low voltage disconnect voltage, and we are at that. So it would recommend that we stop here, which is still 101 amp hours. I'd like to see this to be 1280 watt hours. We're almost there. But I'm curious if we'll get a solid red light eventually up here indicating that the battery protection against under voltage has triggered. So I guess we'll see that coming up rather soon. We might hear the inverter start screaming here in just a minute. Okay, so yeah, we made it to the 1284 watt hours. So at this point, this battery has 100% passed the capacity test. Oh, and the inverter went off. Oh, because we got a yellow light here. So the battery actually shut down, which unfortunately turned my shunt off. I hate that. Regardless, I got a time-lapse video of it, but we saw that it did in fact pull the full capacity, actually beyond the full capacity. So that's perfectly fine. So yeah, I was kind of expecting maybe a red light, but this one's a yellow. I don't think, does it say anything about a yellow light? Or wait, no, okay, that's not a red light. Okay, it says orange light. So that light looks yellow, but that's what they're calling orange. Okay, so that is correct. So it should be an orange or yellow light come on solid. If it's under protection, which it is, just means that one of the cells went below the under voltage and it shut off as it should. So yes, this battery is working perfectly as it should. It passed and completed the discharge test with flying colors. All right, guys, now we tear this battery down to get a look at the build quality and test the low temperature disconnect feature. And, you know, just look at the BMS, and this is clearly going to be a different BMS since it has this smart feature on it. So let's open it up and see how this thing is put together. All right, guys, so I kind of already started a little bit. I wasn't quite sure the best way to open this case because this one is different from the other ones I've opened in the past, where it has this lip, this raised section that flushes up with the top of the case. In the past, they really haven't had this raised section, and I was able just to take a razor knife and slide it underneath the lid to cut the adhesive and then kind of bang it off. This little raised piece is kind of in the way, so I figured I needed to kind of get an idea of how to do it. And so what I've done here is take this chisel, this wood chisel, and just stick it in between these two surfaces, and that seems to be working. I kind of start banging it down first and then tilt it like so, and I think this is going to work. So I've already kind of done the back side and one side here a little bit, so here we go. We're gonna keep banging at it, and it's probably gonna take some effort. All right, guys. We have a breach. Now, let's try to pry it up. Here, let's put it up here. I think we're almost there. Okay, so we're really close to getting this off. I got one whole corner out. And I've got to be very careful not to short anything with that chisel. So maybe I'll just do this. Oh, here we go. This is hard work, guys. There we go. We are open. Now the real nice thing is I did not tear the case up. So we can put this back together. I will definitely say that the other cases, it's thinner around these edges, and these tend to break, and these lips tend to break off. You can usually get them back together, but this one has no breaks or cracks whatsoever, so that's cool. Anyways, so let's see what we've got. All right, guys, check it out. This is definitely much different. We've got 3 silicone covered 10 gauge wires. So normally 10 gauge would be good for 30 amps. We've got 3, which means it would normally be good for 90 amps. However, with silicone insulation, these wires can handle more heat. But I think what I would want to do though is we'll charge this battery back up and pull 100 amps and check the temperature on these. All right, so the BMS is a Power Queen branded 4S 100 amp BMS. It looks like there's a model here that's called S12100 BMS. And then we can see that this the button is installed, has a nut on the back, and it has like a silicone adhesive sealing it up, and then it connects to the BMS right here. Then there is another logo here on the BMS. It says Sir Dance, CIRDANCE. Never heard of that. Interesting. The BMS does have, it looks like it has some communications, transmit, receive, and ground pins on the board. It's not populated. The pins are not populated. I also see some components, maybe some resistors or capacitors, that are not populated for that communication. And then the BMS has temperature sensors here. Looks like one goes into the BMS, and then the other one is going to the battery, which looks to be taped to the side of the cells. I guess let's try to get the cells out. Interestingly, there is a metal bracket inside here. I don't know if you can see. And on the other side as well. And wait a minute. There's a red wire here. Is that a heater? Because nothing specified that this was heated. It did say in the manual that you could push this button to force it to charge in cold temperatures. Did that mean that you can turn the, is there a heater on this, guys? Does that mean you can turn a heater on? Okay, so that changes everything. This goes up a notch if there's a heater. Okay. All right, we're gonna have to get this out. I'll definitely say this case seems to be more durable than the other ones. But there it is. This guy's out. Okay, I was tricked. It is not heated. That is just simply a positive wire that goes to, I don't understand. I've never seen this. That is a positive wire that goes to the BMS. Why does it need that? It does have a terminal that says heat negative, and this one says B plus and heat plus, heat positive. So I don't really understand why it needs this. But I don't see a heating mat, I don't think. Do I? Well, so yeah, the construction looks great. It has this nice metal frame, and in between the metal frame is fiber epoxy board, and on the ends, and it's got plastic straps that also hold, looks like it together as well, but it's mainly held together, the cells are held together with this metal frame. So the build quality looks really good, but yeah, I don't see an actual heater, so I'm a little confused as to what's up with that red wire that goes to the BMS. Everything is covered that could possibly short. That's handy. I haven't seen that in other batteries. So the terminals here are covered in here, and at the top. This feels like one solid cable. That's, well, I don't know exactly what size, but it feels quite large. And then it's also covered with some rubberized or siliconized heat shield. So there is the battery temperature sensor. So we need to test that to see if the low temperature disconnect actually does function. And the balance leads are here, and they're very well protected as well. That's something you don't see a lot. But it is handy for those to be protected because those can short out as well. The bus bars are laser welded aluminum, and it looks relatively the same as other teardowns of Power Queen 100 amp hour batteries as far as the cells and the bus bars go. Everything else around it, this metal frame and the BMS, is clearly different and unique to this battery. Alright guys, so I've got the charger back on this thing, and we're going to start charging it. We're going to try to freeze that little sensor there with some electronics duster. If you take this and run it upside down, it shoots out super cold liquid, and it will freeze that pretty well. So that's what we're going to do. And, oh, actually, let's hook up a clamp meter to see, so we can see the current flowing. Okay, let's get the charging. Charger's on. We got, it's hard to read. We got 49 amps flowing. The light is green. And so let's try to cool this bad boy down. The light turned yellow. The charger went off. And we are no longer moving any current into the battery. So that works. Fantastic. Let's warm it up. And we are back to charging with 49.15 amps. So indeed the low temperature protection does work on this battery. Fantastic. So I want to test this low temperature force charging mode. It says that you can force the battery to charge even though it's in low temperature shut off. You don't probably want to do this unless you literally are in some kind of emergency situation where it's cold outside and you absolutely have to charge your batteries for whatever reason. And it even says here it's not recommended for non-special cases, as charging at low temperature for a long time may reduce the battery life. So it says whenever it goes into low temp protection mode and this light goes orange, it says orange in the manual, it's actually yellow, then we could press the button 2 times and it should resume charging. So let's try that. Okay, so we are in low temperature protection mode. The button is yellow, so 1 and 2. Oh, and it did turn green. And I think that, again, I have to reset the charger. And yes, we're back to charging. So that mode does in fact work. I think it'd be a pretty rare case that you'd ever use it, but it's there if you need to. Okay, so the only thing left I want to do is I want to hook up inverter and pull, like over 100 amps. And I want to verify that these cables are not getting too hot. Because normally you would, like I said, 3 10 gauge cables would be good for 90 amps. And this battery says that you can continuously discharge at 100 amps. So we're going to test this, and I want to make sure that nothing is getting overly hot at 100 amps. I kind of don't think it will, but we're going to check it anyway. And so let me hook that up and I'll be back. All right, guys, so I got the inverter and I'm about to connect the positive wire. Usually when you do this, if you don't pre-charge it with a pre-charge resistor, you usually get a big spark. But considering that I've got the battery off, right? I've got the BMS smart button turned off, so there should be no power. I'm pretty sure I can connect the inverter without a spark, which will be just another useful feature of that smart BMS button there. So let's see. Look at that, no spark, guys. Which means we can tighten this down and we can turn the battery on with this button and not have that spark that you usually have to deal with. All right, let's see. and it's on. No sparks, no nothing. We can turn our inverter on. There we go. And let's go ahead and plug in this heater. Okay, heater's on. We are pulling 63 amps. Says 780 or something on the watts on the inverter. Let's turn it on higher. Okay, well, we are pulling 99, almost 100 amps. So that's good. So now what we're gonna do is let that run and see if, yeah, so we're at 99.5 amps. I'm gonna see if anything gets overly hot in here, because again, we're kind of wondering if these wires here will actually do the 100 amps. Yeah, we're 61 degrees Celsius, 62 and rising. I don't feel anything real warm. We're definitely, okay, well, the meter is actually telling us that we're pulling 100.3. These crappy wires that come with these inverters, I can feel them getting warm. Now they look big and beefy, but they're not very good. But that has nothing to do with the battery. I would say that these bundles of wire here are cooler than this one big, I guess it's supposed to be like a, I don't know, something like a 2 gauge or something like that. We're up to, I don't know, 72 Celsius, 74 there. Nothing super concerning as of yet. These solder joints where the wires are soldered to the BMS look very well done. They are not hot. All of the wire strands are inside of the solder, so we're not missing partial part of the wire. I've seen some I've seen some crappy jobs where they don't actually get all the strands in the section they're trying to solder. And same thing on this side. Nothing getting overly hot. I mean, just actually, it feels just slightly warm to the touch, really. It's 78. The cells are reading around 60 Celsius. I'm sorry, that's not Celsius, that's Fahrenheit. So 78 or 80, 75 Fahrenheit. Not even a problem. And let me show you what this big wire that came with the inverter's doing here. It's at 90, so you can tell that big wire is much warmer than these 3 10 gauge wires. I'm gonna call it good. Again, we are pulling over 100 amps. So yeah, there's nothing heating up. The battery can easily sustain 100 amps continuous without any problem. There's no problem at all here. So yeah, so it's a go for me. And if you guys want to pick up this battery for yourself, I'll leave links in the description. Power Queen gave me a discount code. It is BRAD3, all one word, BRAD3. And I'll put that into the description as well. And you can use that discount code at the Power Queen website for any of their batteries. And I think you get 3% or something like that off. But But anyways, that's going to be the end of the video, and I'll catch you guys on the next one.